Thank you. Okay. For today's lecture, I'm going to go a little bit, we're going to expand the scope. Okay, so I talked briefly that we did the cyclone investigation. So now I wanted to put a focus on two parts. One is the commercialization of forensic work in a disaster setting. And the other one is really how do we integrate it with other aspects of disaster, okay? And in our focus is in grid resilience, okay? So power grid usually is closely tied into any kind of disaster scenario because it's life dependent, right? And so in this particular study, which is sponsored by the National Science Foundation, we are teaming up with the University of Puerto Rico. So it's really an integration of civil engineers and electrical people, especially the power electronic people, okay, in power grid system people. So in our team, we have Yamelka Baiz. She's our assistant professor in electrical engineering. She's also the lab manager for power, high power electronics. Myself, Miguel Pendo is our department's one of the senior faculties in geotech. Okay, so structural geotech, and then Madhav Majureka, he is in the power system again, and Wengwu is geography. Okay, so we do a lot of GIS in this work. And then the last but not least is Dr. Agustin Irizarry. He is from Puerto Rico.
Everybody are from UNC, Charlotte?
No, except for the last person. He's from Puerto Rico, Mayagüez University. Yeah, so he's local, okay? And so I keep emphasizing forensic is a really, really good business right now because of climate change, because of global disaster, okay? So every time there is a disaster, the money becomes really, really expensive, okay? So the middle number is in billions US dollar in 2011, okay? So the Japan tsunami 2011 was $210 billion, okay? I don't know how you convert to lakhs or crores in Indian currency, but the number is tremendous. Okay, just to give you a state like Tamil Nadu, your state budget, equivalent to the U.S. is probably 1 or 2 billion. Okay, so North Carolina, our entire state budget annual, including everything you can imagine, making roads, agricultural, everything is about $1 or $2 billion. Okay, so our highway budget is usually runs about 200-300 millions. Okay, so in the billion level, any of this storm is equivalent to 15 states in U.S. that is suffering. Okay, and so looking at all these numbers, you quickly realize that somebody has to come up with the money, okay? Either to repair, rehabilitate the infrastructure, rebuild homes and stuff. It's a huge amount of money. And when you go deep into who paid for those, you found that humanity efforts, NGOs actually are putting a lot of money, okay? Gifts, okay? So annually, I think the U.S. still leads the world in personal contributions, donations and so forth. So all these monies you suddenly realize are actively being drawn in, for many efforts. After the 2008 Sichuan earthquake in China, they found a phenomenon. So in China, they use a lot of WeChat, social media. And there are tons of people who suddenly start, doing fundraising using social media, and many of them are not real. So a lot of schemes, were being devised because of people suddenly realize that people are passionate, for suffering and so forth. And so this become a huge business. And this shows you the different kind of, and you can recognize quickly earthquakes, hurricanes, earthquakes, hurricanes, earthquake, hurricanes. Okay, those are the big issues. Flooding is slowly becoming very, very important. Okay, and so most of the time when you have a cyclone type of disaster, the really, really critical aspect is to differentiate what is the cause of the failure. Okay, so forensics. Okay, so forensic engineers become very, very useful. But of course, you need a lot of experience. And these are the major companies in the U.S. that are doing forensic. With Jennings, Parsons, Exponent, Thornton Tomasetti, Arabis started from England, okay, and now become an international company. Hack, okay, Hack Engineering, Sinclair, all these are major U.S. Every one of them could have a couple dozen engineers doing just forensic, civil forensics, okay. Exponent is a very unique company. They are very well recognized Exponent, but they started their business in car forensics. So they work for the top 4 automotive manufacturers. In fact, their CEO used to be a vice president in the General Motors. Okay, so they started from automotive and then slowly branching out into civil and other components. And the reason is because they recognize that forensic engineers is about investigation, regardless of your discipline. So they will hire civil engineers, train them to become forensics. They hire mechanicals, train them into automotive forensics. Okay, and you get, suddenly you get, and right now they are the Americans leader in lithium-ion battery fire accident. Okay, so you realize that in the automotive business, now everybody wanted to drive electric cars. So on our campus, we have many charging stations. So people park their car and they charge their car when they were working. Okay, and so those electric cars are all lithium-ion batteries. Lithium-ion batteries, the biggest problem is it catch fire, it blow up. Okay, much worse than your typical car getting caught. Okay, and so, but the technology is so new, so there are only very few experts in battery fire today. Okay, and Exponent is one of the leaders in this area. Okay, that kind of research, you need big facilities. Okay, you need to put packs of batteries and then you blow them up, see what happens. Okay, so those are the, we talk about mock-ups. Those are much simpler experiments than civil, blow a whole building up. So but that Exponent also has very big facilities for testing civil structures. You can build a 1-story building and blow it up in their facility in Arizona. Okay, so those are really real players in forensics. Okay, and they are branching in. So Arab, I know they have India representation. I mean, there are branches in India. Okay, so I can imagine very quickly those will become the very influential business partners in forensics in India. Okay, and geotech is a little bit unique in the sense that the companies that are doing geotech forensics usually are specialized in geotech projects, tunnels, pavements, and so forth. And so Stantec is one of the larger players in the U.S. in geotech. Okay, and of course there are many others that I didn't name them. Okay, there are many small forensic companies, over 1,000, that we cannot know. Okay, some companies are as small as 5 or 3 people. Okay, so in Charlotte we have several small forensic companies that just hire 3 or 4 people, and they would do everything from a crane collapse to a structural damage. They would do everything. Okay, and so because our school teaches forensics, so every year we know that we have at least 3 or 4 students in the structures group that will hire straight into forensic investigation. So our group have a lot of network because we teach the class. Okay, and so our students grow. And when Dr. Young, David Young, teach the forensics, he's the only one that teach. He had been teaching that class for the past more than 20 years now. and his class is always packed. Okay, many students want to get into this area. And of course, there are a lot of individual inspectors. Okay, there are two technical councils, as I mentioned, in the U.S. The one that I'm involved with is the ASCE, and then there's the National Academy of Forensic Engineers. Okay, and this is just in civil engineering domain. Okay, there are many other related, partial related, somehow related groups, such as NGOs, insurance companies, law firms who just do civil forensics, disaster relief group, emergency management, analytics companies. Okay, so there are many people who are interested and who's been making money out of this business. Okay, some of the companies' symbols is provided. Okay, now who pays for all this? Obviously, government and international relief efforts. Okay, and the government disaster prevention efforts, which is huge money. For example, New York City itself has earmarked, I think, maybe $500 million just to help them prepare the city against climate change, the next big disaster coming. Okay, so those are significant amount of dollars. Okay, if you work for a consulting company who has an interest in this, you wanted to be part of that effort. Okay, and so, you know, as early as you start exposing yourself to this kind of topics is very important. Okay, and then donations and foundations, as I mentioned. Okay, it's really important. There are a number of companies that are very interesting because they derive their business from risk assessment. Okay, risk not in the sense like what we commonly speak. We're talking about statistical models. Okay, so there is a company called URS. It used to be called United Research. It's a British started company. Okay, and so they quickly grow in size and they move to California. And their predominant role in the 50 years ago was to assess various infrastructures for their earthquake risk. Okay, so these are a very unique group of people because they are good in statistics and modeling, but they are not necessarily structural engineers. Okay, so they look at a structure, they do look from a totally different perspective than you and I. And I work with this kind of companies. I start learning from what they do, and then turn around and look at what we do. And I start learning about, oh, you know, if you can assign a number to a structure, a damaged structure, that number has significant implications. Okay, because if you just tell somebody, hey, you have a beam damage, you have a wall damage, the guy, most people don't understand what it means. Okay, they just want to know, is my house safe? Can I go into my house? Okay, for the insurance company, they don't really care. They want to know in Trichy, okay, how many % of the homes will be flooded next time a big cyclone come by? You know, and then they will assign, and they want to know the probability of your house, because if your house is highly probable, they will ask you to buy flood insurance. See, they don't necessarily need to know, hey, if next time it floods, my house will not be flooded, but they want to know your neighbors included. Okay, so you quickly realize that because every industry focuses on different aspects of disaster, their interest on what data they are interested in may vary. Okay, and that is a huge lesson for me. Okay, and of course, so you realize where forensic engineers can contribute. Okay, we can contribute in on the ground casualty establishment. Okay, so like many of the times, what we do, we go into the disaster areas. We quickly account for the damaged buildings. Okay, so that is one contribution we do, and the other one is to validate reality. Okay, a lot of times the government doesn't really know what happened because they couldn't get access or they don't have the expertise to know. Small countries, especially those very poor, underdeveloped places, they don't have a lot of engineer. So whenever there is a disaster, one of the biggest challenge for the government is, I want to know how much it's going to cost me to repair everything, okay? And I want to know how do you get that number, okay? And that's where forensic engineers come in, okay? I didn't cover a lot about the economic aspects of disasters. So you usually can help them quantify how much it would cost you to repair your home to certain degrees. And that number will quickly add up, and that's what the government is interested in knowing, okay? Don't tell me your home needs, 1 crore to repair or 1 lakh. But they want to know all the homes combined, because that's how they think. Government, they don't go into too much details. That's the business model, okay? And then, of course, there are secondary benefits which you may not necessarily have the expertise. But if you're working with a group of engineers in a big consulting company, you guarantee somebody in your office know how to do repair, how to assess what kind of techniques to rehabilitate, strengthen your beams, and so forth. Okay.
When such disaster occurs, Professor, and the particular house completely gets washed out, and it's unable to reuse, we cannot do the repair work and other things.
Yeah.
Will the government pay the compensation for rebuilding the complete house as the previous property?
Yeah. In the U.S., FEMA would pay for your temporary housing. They will move you somewhere. You stay in a hotel for a while. And then they will pay for the repair of your home. Yeah. And that is why it's so costly to the government whenever you have a disaster.
When they ask such sort of validation,
they will invite consultants too.
We cannot exactly predict, right? We
Yeah.
can give it in either we can give it in higher side. If we are in lower side, then
you get in right. Yeah.
So normally everybody will be quoting in the higher side.
Right. Yeah.
Speaking, that costs $5 million.
Right.
But they might quote for $10 million
Yeah.
or so. That's not a problem. They don't ask why such a great difference where for A and B.
Right.
Whereas for A it's only $2 million and for B you are giving $10
Right.
million.
So the usual process. So in insurance company, they have an army of people who are doing this. They calculate, and they will come and interview. Your house. They will go do a walkthrough. Okay, wall damage, wind, and then they go back and do calculation. So they have a standard, like the Masters catalog. They have a standard calculation method. Yeah.
So they will do.
They will do, and they will ask you. They will ask you to fill out personal losses.
So in that, if there is any discrepancy, they can add or deduct accordingly.
Yes. Yeah.
And they can alert the
Right. And it's not very scientific, because that's why there are litigations, because they will be doing thousands of homes. So sometimes you get less, so you have to argue, and you're not happy, you sue them. It happens all the time. Yeah. And so this is huge business, and anytime insurance involved, we're talking about millions. Okay. After Katrina, we have friends who moved to New Orleans, the city that was submerged, because they expect the job would last for the next 10 years. And some of our areas are still recovering.
Katrina was in the western side of the US.
No, the southernmost. Yeah. New Orleans.
Florida.
No, New Orleans. It's in Louisiana, next to Texas. Yeah, that city is known, it's like Pondicherry. It's a French-speaking town. And they are known to be lower than sea level. So when Katrina happened, the whole city was submerged for months. Yeah, so that's, so their problem is sustained. Even today, I think a quarter of the population has not returned. Yeah, I'll talk about some of those social impacts, okay, to Puerto Rico. And I want to introduce, so this is Image Cat is a very good friend of mine. He's the owner is a Japanese descent American, okay. And so he started this company. There are only no one structural engineer when I was working with him, okay. I think one of his relatives worked for the company. Maybe he's a younger brother or whatever. But they only have 2 geographers who do geospatial analysis. And they were doing very successful because he is very creative. So they get a lot of World Bank and the FEMA and Federal Highway grants to just quantify the risks of those disaster areas. So they would do a lot of assessments to any time there is a major disaster, his company will be the first one in Washington, D.C. to talk to the World Bank and see if they can launch a study. And they are one of the first companies. So they do a lot of, this is a relatively new, and they have also representatives in England, Beth, one of their engineers in England. And they constantly updating their website. So the website is their major portal, okay, to communicate data, okay. And then within the portal, they have many tools developed, okay. So for example, seismic. So they even before Google Earth has a lot of the time history analysis, they provide a Google-like website. Okay, and then they provide real-time aerial images of the disaster. Okay, and so for example, Haiti, we have several universities worldwide doing real-time data analysis. All you do is just open up the Google Earth picture and then look at the building, and then you start tagging. Okay, this one I think it's red, green, blue, and suddenly he has the whole Prince report, Port-au-Prince, the major earthquake area, all the buildings assessed, okay? And this kind of assessment is really important because it gives people a sense of the significance of that particular disaster. So they develop a lot of those tools. They also develop in the health monitoring domain that they can use remote sensing data to assess breach condition, and they call it Breach Doctor, a software, okay? So this is a very visionary company that do all this. And Ronnie Gucci, the owner, he URS. So you know that his background is in risk modeling, okay? And he make a lot of money selling his data to insurance company for hazard, and all that kind of, okay? So this is one very unique area, and many government agencies starts to pay significant attention. In the U.S., it's very political. FEMA versus the Homeland Security. Okay, one is supposedly more focused on terrorists and that kind. The other one was more disaster. But you quickly realize that in many areas they overlap, especially when you start talking about data analytics. Because once you develop a geospatial tool for a particular disaster, how hard is it to extend that to other disasters, right? If I can do a major area mapping of all the flood potentials, I can use the same geospatial data, include terrorist attack, other kind of scenarios, earthquake, and then suddenly you realize you have a very powerful in your hands. Okay, just for information, a few years ago when we submit a proposal to the state of New York, and they are interested in projecting the climate effects onto the New York State. Okay, and so I was talking to, and at that time, we trying to put our focus on energy grid resilience. Okay, so based on my background in the Philippines, we have a lot of geospatial mapping of disaster zone. Okay. And at that time, we also have experience in simulating storm surge, flooding potentials due to strong wind. Okay, so there are some software that we are integrating. And at that time, we talked to the Gas Institute. Okay, so the Gas Institute, a few years before we submit our proposal, has already got a grant from the Homeland Security Department. And their development is to develop a real-time software, a web-based real-time software, so that whenever a cyclone comes, especially on the East Coast, okay, they can tell people can get to their website. If you still have electricity, go to their website, and then you can see where are the areas that they have lost power. Okay, so the Gas Institute, they work with natural gas.
how is the academic side in Philippines, professor? The college, institutes, universities.
What do you mean?
How is the education quality
In
Philippines?
in the Philippines? Okay, so of course the University of Manila is the best.
The best.
Yeah, and they have the island that we went to. They have a few universities, but there's no engineering school.
So they worked with you when you were.
Yeah, we are not directly work on our project because we already have our team, and then we actually work straight with the Institute of Civil Engineers in the Philippines.
They have a very strong setup.
Yes, yeah. A lot of their, like Eric, one of the faculty that I have interacted, he went to Japan. Because Japan, the closeness, so they, anytime Philippines has any issues, the Japanese will be the first to get there and do the assessments. Yeah, so a lot of the Philippine engineering professors who's interested in this kind of study would go to Japan, get training. Yeah. Well, our in this domain, we are weaker because in America, we don't have, at least a few years ago, we don't have major cyclones. I mean, the Pacific is the largest, the ring of fire. We are a lot weaker, but still we are better than the Bangladesh, India area, because your wind force is even less than us. Yeah.
So in this project,
Yeah.
the climate change effect in Europe, you said, it was through, sir, project?
Climate
That project,
change
climate
affecting
change in
Europe.
In Europe?
You said, sir.
Oh, no.
Oh, no.
Climate change in general, not in Europe. Yeah.
That project was through, sir?
Through National Science Foundation.
Yes.
Yeah.
You implemented that?
No, she's asking that is the project is sanctioned.
Sanctioned?
Oh, yeah. Most of my study are supported by the National Science Foundation.
Okay, so what
Yeah.
was the proposal, sir? What are the effects you consider?
Okay, so initially we are studying extreme cyclones. Okay, so I will discuss in a minute. The Philippine GIAN was the highest wind speed, recorded ever. Okay, and then we got funding for Maria, which is the largest ever on the Atlantic side. And so that's why we get our funding. But the Maria is unique in the sense that it's the first time we integrate with grid resilience study. So our focus is applying forensics to the grid failure scenario and see how we can determine the cause of grid failures. I will explain in a minute. Yeah. Okay. Any other questions? Okay, good. Yeah, so I wanted to show you this because many people who get into this, and when I was in Taiwan 2015, the Thai Power invited me to give a lecture, and they asked me a lot of questions because when you get into health monitoring, you develop your sensors, right? Then it becomes a business because you want to sell your sensor, okay? And how do you do that? It's a very interesting, very protruded, and everybody know that disaster has the most money, so they wanted to be able to get ready, okay? So Thai Power has a group that develop wireless sensors that they are installing at different locations, geosensors or structural sensors. I'm like, look, this is something I do 20 years ago, and I explained to them, just by developing the technology alone is not sufficient, okay? There are many, many questions that goes into the instrumentation alone, okay? Is your sensor going to sustain the wind force that we're talking about here? When the bridge collapsed, what happened to your sensor? Okay, and that is why you notice that from my publication history, I start with contact sensors, then I move to remote sensing. Because I realized that when there's a disaster, you cannot go and check your sensor. You have to scan it from a distance away, okay? And so those are our business issues, okay? And also, so I asked them, a lot of them are software driven. In other words, you have your physical sensor, right? But all your controls are software driven. So who's going to go back every year and you have hundreds of sensors, thousands of sensors that you're going to go back and upload the updated software? So it is a business model, and a lot of companies are start doing that, especially in smart grid. So they train a whole team of people that will just drive around transmission lines and then update the software. And those are critical issues. But when the tower goes down, whatever software you have on there is all gone. So those are really critical issues. And then how much money do you have to invest? Okay, I have a very good friend, Srinivas Alampalli. He's the head of research division at New York State. Okay, so New York State is very unique in that they have many small bridges. So when I start doing my wireless sensor development, I have a goal. I want to develop algorithms so that the cost of the sensor and the software will not be over $1,000 US. Okay, why do I come up with $1,000? Well, because that is how much money you average it out. They spend on inspecting a bridge. They send somebody, drive to the bridge, look around, do some crack measurements. That's about $1,000. Okay, so your technology cannot be more than how much they send people to inspect a bridge, right? They still need to send people to inspect the bridge, but your sensor cannot cost millions when the bridge is only cost $20,000. Does that make sense? So a lot of those less than 10-meter bridge, they cost very effective, maybe a culvert. So they're not costing a lot. You cannot use technology that costs more than that. Okay, so I always go with low cost. And when I start preaching that, Alan Parley told me, Shannon, if I base on your calculation, the bridge in New York State only costs $100. So your sensor has to be less than $100. Oh, that was a real challenge. But how do you account for the value of your technology? Is a real business issue. A lot of my contemporaries, professors who into this area, eventually they start their own company. But you notice that they may be successful in getting 5, 6, 7 bridges, and then after that, they don't have a lot of business because maintaining that takes a lot. And when you are a professor, you don't have the time to go and deal business because you have to sell your technology to DOTs, right? You have to go to Tamil Nadu Bridge Division and tell them, oh, how great is my technology. When we start doing the remote sensing for bridge monitoring, we did survey of all the 50 states. It was then it hit me like a brick wall. Whoa, wait a minute. No matter what technology I develop, I only have 50 clients. 50 clients. Wow, that is a hard sell. Okay, because you go to departmental store. One store you have many clients, right? So that's how you do good business. But if you have only 50 clients and you have many people who develop sensors, it's not a good business model. They can only use one, right, or two. But then there may be 50 companies that is doing this business. When we start doing this, probably more than 30 years now, okay? At that time, I'm very close with a MIT professor, Dr. Ken Messer, okay? And his expertise in ground-penetrating radar, okay? At that time, he already demonstrated, yes, it's very wonderful if you can drag the radar on the pavement and then scan, and then it will tell you, if your pavement underneath, there's hole. That is wonderful. And I asked him, and the biggest question at that time, 30 years ago, everybody asked, how fast can you scan? Because if you scan pavement, you're miles and miles of pavement, right? And at that time, if he can do 10 kilometers per hour, it's very good. Because the amount of data was just tremendous, and the computer at that time could not process it fast enough. So I asked him privately, so what is the biggest technology hold up for ground penetrating radar to be successful? Computing time at that time, okay? Now you can drive a GPS GPR and running at 40 miles per hour and scan. Okay, so technology finally arrived, but after so many years. Okay, is every DOT doing that? No, still not. Why? You think about how many bridges the U.S. has. We have 600,000 bridges, highway system alone. How many GPS cars? Yeah, I mean, I know people. The quickest people I know that can drive from East Coast to West Coast with 3 days. Yeah, so you're flying over the bridges literally if you have to cover so many areas. So that is the essence. Yeah, I mean, Singapore maybe you can do it on a monthly basis, but not for a country like America, India, China. So those are business issues that eventually people who do health monitoring would go into. Okay, that's why we need geospatial. Okay, integrate with GIS. So those are really early on issues. Okay, but anyways, extreme hurricane. So whether you agree with climate change or not, okay, there are some really, really significant events happening. Okay, so Michael was last year, 160 miles per hour wind. Entire one village was completely flattened. Okay, in fact, the picture was so funny because all the entire beachfront, every building was down but one. So people start looking at that one building. It's like, oh, they must have done something right. Okay, well, what happened is the state of Florida has been changing their minds about the requirement for wind load on their buildings. Okay, and because they have a lot of poor people. And poor people cannot afford strong buildings. And if they live in very old buildings, they cannot update it to the new requirement. Okay, so they have relaxed over the years their wind load requirements. Okay, but those are nonetheless, it's very important, even though you may see in English units, miles per hour, but if you translate to kilometers per hour, those are very significant winds. Okay, why? Because hurricane wind is usually less than 70 miles per hour. Anything that is, so we call it tropical storm, okay, less than 70 miles per hour. Anything above 70 miles per hour, then it becomes, 74, becomes hurricane, okay. Now, tornado, America has a lot of tornado. Tornado is 112 to 300 miles per hour wind. That is significant. Why? Because you see, those are all recent windstorms. All of them are above 100 miles per hour. Okay? If you know about building design against wind, okay, when you have low wind speed, you wanted to protect your windows from getting broken because of the wind pushing, right? But when you have tornadoes, which is a much smaller cyclone, the biggest force that is actually suction force, okay. And so when we tell people to protect themselves against tornadoes, we tell them open all the windows so that there's no negative suction force from inside cause your building to implode, okay. But when you go to hurricane area like Florida, we tell them you have to shield your windows. You have to board it up, okay. Use wood panels to protect, because that was the direct wind force. Okay, and so suddenly you have a hurricane, the force of a tornado. What do you tell them? Open the window or close the window? You have some real physical problem here. Okay, this all deal with physics. And
why such things are frequently occurring in the United States, though, sir?
The tornadoes?
Because of the sea?
No. Because of the jet current. The jet current, yeah. So we have a big area that is really large and flat. So tornado would likely happen when the dry air and the wet air encounter. Yeah. So we have a lot of gust. Yeah.
It's not the attraction between the sea and the...
No. Tornadoes are usually away from the sea. Yeah. Mm-hmm. Well, that's something I need to address in a minute as well. Okay. But anyway, so cyclones are not dangerous. I mean, there are cyclones which is even higher speed than what we saw. But the important thing is when it make landing. Okay? When it's winding down, when it's not so strong that it make landing, okay, we can survive, right? But when it's on its peak force and make landing, then that's when people start suffering. So I think this is our navigator's work. So we plot the wing pressure, the eye pressure, and the wind speed. Okay, and then we identify when it make landing. So Hurricane Irma was major disaster in the Floridas. Okay, this is all 2017 issue, right? 2018. Anyways, you can see that it arrived when it was peak wind speed in Puerto Rico. Okay, and then Maria, which is another one that comes in, and then it made peak when it hits Puerto Rico. Okay, so this is when, the worst that can imagine happen. Okay, and they are not, so wind force is one we keep putting emphasis because that's what we can measure. But carries along with the strong wind is heavy rain and multi-hazard. Okay, flood, storm surge, wind, and landslide in the Puerto Rico case. In Florida, we don't have a lot of mountains, so there's no landslide. Okay, no significant landslide. But the problem is, when you have multi-hazards, how do you know your structure, how it's going to fail? Okay, even if it stands wind force, it gets flood or gets wave hit, you have many failures, okay, possible failures. And then there are more and more volcanoes, earthquakes, tsunamis, heat wave, and in the U.S. especially, forest fires every year. A big chunk of California will be burned up, okay? And all these are just financial burdens to any country, any government, okay? And from a climate perspective, okay, so climatologist has already told us that we will see less and less tropical storm, but we will see more and more really big storms happening. Okay, so this is the history of U.S. Annual severe weathers. And you can see that, I mean, the statistic is not clear yet, but you can see from here, it goes this way, okay? Suddenly you have a lot less events, but you have more spikes that peaks beyond the limit.
So once a 5-year data?
Yeah, every 6 years.
2005, 2006,
right, yeah. 17-year data.
12 to 17.
Yeah. Mm-hmm. And before we have some, but, and again, climate study data are getting improved.
Complete outline for the entire United States?
Yeah, entire United States. Oh. Yeah. Uh-huh. So this kind of data is actually very important.
They are very happy to share all these things.
Oh yeah, we love to share. Yeah, yeah. This is all public domain data.
Some meteorological data here, it is a little bit difficult to.
I know. Yeah, and that is something that you cannot do that. Yeah, because this information. Yeah, we pay tax. You should share the data. Yeah. Okay, and then ASC 7 in 2016 updated their wind load requirement. Okay, and in the U.S., Florida is always the strongest wind speed. So even in 2016 ASC 7 code, the strongest wind speed is still 200 miles per hour. So remember the wind speed I showed you early on? In just 2 years, we have several that is almost reaching 200. Okay, and that is critical. Okay, and we have updated our. And another thing is, so there is a wind, warm weather and cold weather. Talking about the cycles. Okay, and then you can see that many of the states have already increased their frequency for Category 3 and above. Okay, so these are all our students compile this data. Okay, and then the velocity pressure decreased for different states. Notice that California, they reduced the risk, okay, for California. So it actually decreased. But Honolulu, San Juan, Texas, all increased. Okay, New York City. Now, this data may not be completely scientific because there are a lot of politics going into it also. Okay, so the local municipals may fight and argue, hey, if you increase my wind speed, it will cost too much for our people to our city is not that rich. Then they will argue and ask ASC to reduce that. Yeah. So I always tell students, this kind of data mean very little to me personally because I've served on those committees. It's just a bunch of old guys sitting together and this is the number I want. Okay, anyways. So why so this project was sent by American Society of Civil Engineers. And we asked some of the experts in different areas to get together and went. Why is this study so important? The wind speed was 195 miles per hour. It was only 5 miles per hour lower than the maximum that the American code designed. Okay, so we want to know what this means to us. Okay, so our committee are visionary. In fact, we didn't come out and ask, so they call us and ask the Forensic Council to send people to do this. Okay, and we didn't see this because by the time they actually put the money together and send us there, all this has been cleaned up, or most of it. Okay.
Most of the structures are concrete?
No, some concrete, masonry. Yeah, and because these are very poor village, so a lot of wood structures, and then the roofing. So you go into structural details. Those are not designed for the cyclone. Yeah, strong cyclones, and as I mentioned several times in class, the reason we went there is because in the U.S., the insurance are separate. For the coastal population, wind damage and water damage are separate. But this becomes a critical issue. Why? Because you realize that when the wave gets bigger, then how do you separate the two, wind or water damage? Okay, so there need to be a science that help us differentiate for every damaged building what is water damage, what is wind damage. And that is why we invite those forensic experts together and go and do this study. Okay, and so for this building, it is very obvious what is wind, what is water damage. This is near the Leyte Island Airport. Okay, the Tacloban Airport. So you can see all these are watermarks. Over a month or two, they will start showing. Okay, because the seawater gets in and then it starts to corrode the paint and everything, so those were coming out. And this is watermark. So everything above must be wind damage. Okay, so this is a very basic, clear-cut differentiation, but most of the buildings will not be so easily differentiated. Okay. And then I mentioned about the ground truthing, about the force of the wave. Okay, so we use the rock walk to calculate, and using very simple wave models to determine how far and how high the wave has come up to. And then some of the things, so this is a rooftop analysis. So we look at the roof damage and then point at the direction. So you notice that this picture, the roof, this part was wind damaged, okay? But the rest are intact, okay? So if we assume the wind coming in this direction and then you plot it out, suddenly you have this very erratic damage mode. Okay, what's happening is you have to keep in mind, hurricane is a very dynamic process. The wave is keep moving. Okay, it has this big cyclones, but there is something that's happening as well. Is that when you have such a high wind speed, okay, many little tornadoes actually happening within this huge wind speed. Okay, and that is something that until 2018, Hurricane Irma, we have not documented, because now the remote sensing, the satellite imaging have enough resolution to differentiate within a cyclone. Before it was usually just an average value or the peak value, but now we were able to see a lot more in the storm. Okay, and so this is a direct evidence of the scientific fact that when you have a very strong, big wind hurl, there are many, many tiny little ones that may be happening. Okay, and those are not necessarily a climate phenomenon, because those may be local topology would suddenly stir up the current. It's kind of like if you take a cup of water and you stir, and then you put a pencil in there, you suddenly cause a local anti-current. And this is what we believe what's happening. Okay. And then water and wind damage. So we did a lot of those geospatial analysis by using Google Map. And you can tell, how the wind and the water damage distribute. Okay, so those are very useful information, and then we can tell the distance, how far are the water damage and the wind damage map. Okay, and then some secondary data, such as a lot of boats were lifted and moved onto the shore, and you can do geospatial analysis and realize that a lot of those, especially in the Tacloban city here, the wave must be extremely high, okay? And so there's an argument. So some of the Philippine, Japanese papers using climate models, they don't know. I mean, so the wave height is really the argument, the storm surge height. So our study, we believe that the wave heights are more than 20 feet. But some of the study claim that it's only 10 feet. So there are a lot of debates on this. Nobody see. Okay, people who actually saw it is dead. Okay, so we have to do the ground truthing and so this, and then provide the scientific explanation. So this is one of the theories that we are doing in our lab to see how the wave travel here, and then when they converge, is that opening would drive the water table up. So a lot of those kind of analysis is still undergoing. Okay, and then of course for the power utilities, we see a lot of towers down and poles down and so forth. But when we do the Philippine studies, that was not our focus. Okay, and so you see communication towers completely down. Okay, so this is wind. This is not storm. Okay, and then this can be wind, can be flood, can be a number of things, or even buildings leaning, causing it to collapse. Okay. And then we were very fortunate or not fortunate to be able to involve. So NIT Trichy and TrackStep pay for our trip to go to Vizag to investigate the Hudhud. Okay. Now, Hudhud is very unique in the sense that it's still the most expensive cyclone in India history. Okay. So when we went there for 4 days, so using GPS camera, you can see exactly where we have been to. Okay. And this transmission tower may be several kilometers inland. Okay, so you can imagine the wind force. Okay, even so far into the Vizag, you get this kind of Andhra actually. It's going beyond Vizag. You see this kind of transmission tower down. Okay, and then this particular building is very unique because this is in Alto Naga. The building is facing north-south, okay? I mean, approximately. And then only the front and the back had this significant impact, okay? Completely crashed, but the sides are all intact. So the locals, we talked to the professor from Andhra University, and he was telling us that there was this two wing, one in the separate by a couple hours, okay? And so they come in at different times. So there's some phenomenon that was not reported by the meteorological society. Okay, but we see that. So this is the building. Okay, this is a vertical north, the true north, and we found that the front damage or the back damage depend. Yeah, this is the back. This is the front damage. Only and the sides are all intact. So this is a very interesting ground truth phenomenon that we don't have a lot of answers for. Okay, and but more interesting is we recently so we submitted a paper to ASCE on reporting our I'm making corrections And what's happening is, of course, all of you know that it caused an avalanche. Hood caused an avalanche in the and this I think in Nepal. I think that was like 1,000 miles away from the coast. So my theory for this is a lot of those strong wind force. Okay, they may deviate their path, and if they were allowed to go inland, the force will cause significant amount of damage. Okay, of various types. So the big snow was actually not because of that hood. Okay, but the wind force was one that caused the avalanche. Okay, and then we also did the wind damage profile. And Vizag was very fortunate because the coastal area was very well prepared, so there's not a lot of water damaged structures. But even so, some of the wave from the TV, you can see the wave are very high up, the storm surge. Okay, now Irma. So Irma come in as a surprise because Irma was 180 miles per hour wind maximum force. So when Irma happens, everybody was very, very scared. Okay, but we were not so well prepared because in Florida, especially the coastal area, a lot of powers were out. Okay, and people were not having power for weeks. Okay, and the storm surge was significant. So this is the Florida Keys. It's a string of islands, and you can see most of the structures were all damaged. Okay, but this is what is interesting. So St. Augustine is a city that is actually near this site, almost to Georgia, on the top, northern Florida. Okay, so we know that the path of Irma comes from the bottom up. Okay, and that's why Florida Key, which is the bottommost islands, were damaged severely. But that area, we actually see a lot of major storm impacts. Okay, and tornado. So they actually have documented tornado damages. I have not shown those pictures because we have not physically investigated those buildings. Okay, so I have pictures but from somebody else, but these are all pictures. So you can see I do it again. So the wave actually were able to wash out a lot of the coastal areas. So, my theory is that because this storm drives the wave, travels from so far away, so part of that wave actually impacts this area and rather than the rest. So if you go to Miami, which is just right above the Keys, they don't have a lot of water damage. But somewhere this far up, it takes almost 4-hour drive. You see a lot of wave damage. So, how do you explain that? Okay, so those are the things that we're analyzing even today. So we went and go to all the cities that were damaged and do our structural assessment. Okay, and we did more than 1,000 buildings. Okay, so we were able to do a very significant quantification. Okay, but Irma is still nothing like what happened in the Philippines. Okay.
I think in this zone there is a bridge connectivity between the sea and the next island. No? I'm not sure.
Yeah. There is a whole string of bridges. Yeah. But the bridges were not significant damage.
Oh, that didn't.
No. Yeah. Mm-hmm. But by the time we do this study, our objective is the power system, power grid. Okay. And so you see those stars, those are all tornadoes. So we have physical evidence showing that when Irma comes, it actually triggers a lot of tornado. Okay, so now as a structural engineer, you have to really scratch your head. Okay, so do I design it against tornado or do I design it against hurricane? Okay, because now you know that the probability of having a tornado when you have a certain wind speed is more. So you have to design higher. So now in ASC, the biggest argument is really, it doesn't make sense if you're trying to push, especially considering climate change, push your wind speed to higher wind speed. 250, if the building is down by 300, so should we move to 300? This goes beyond reliability-based design. So ASC 7 is reliability-based design. So now people are are saying that forget reliability-based design. Those are, not going to hold for climate change. Climate change is something that is in progression. So there is no statistic for you to calculate reliability. So why do we even base on reliability? Okay, so design for the extreme. A group of people are suggesting. Just design for a ridiculously high wind speed and people can pay for it, go for it. It's a realistic argument for civil engineers, especially structural.
Based on the number of buildings that is damaged due to that, we have to go for the majority, obviously.
Yeah, but they already damaged. But problem is you cannot predict for the next 50 years it's going to happen again. Yeah. And there's no statistic to back it up.
Same thing when we were predicting this. Now we are in 2015. If it was happened in 1959, we don't know that it has occurred this much of impact.
Right. Yeah.
We cannot
Exactly. And so this is actually one of the very interesting things. So when we were in the Philippines, we meet with the government official and the local civil engineering president and so forth. There's one old engineer. He just keeps saying, 50 years ago, that island had exactly the same stone. But there's no proof. But he was he was very young. He was older than me, but he was a little kid, But he is like, I remember vividly, we died so many people, and, that's why we need better forensic records. Yeah, disaster records.
Before 50 years, they don't have any data.
No, yeah. Mm-hmm. Yeah, 50 years ago, the Philippines, those are just fishermen villages. Yeah. So this is another challenge for us. Okay, so let me go way back. I think I jumped all the way down. So, how do I? Okay, now we're back. Okay, so we spent a lot of time in Puerto Rico studying the hurricane impact to the power grid. Okay, and the reason is because of system resilience. Okay, Puerto Rico is a very sad case because after the storm impact, the disaster was so humongous, and then on the continental U.S., people don't know what to do with Puerto Rico because they are not one of our states. Even though they belong to the United States, but most people, if you ask people on the street, they think it's a totally different country. Okay, so the predominant language is Spanish, and we don't understand them. So there are many issues involved.
Is it like a tribal place?
It's not a tribal. Yeah, just historically they belong to the U.S. Yeah.
But U.S. is taking care.
Yeah, supposedly.
Earlier it was Spanish.
Yeah, and that was one of the issues. So after this, if you follow the news, Trump was just the new president, and a lot of people criticized he moving too slow, and the power company is corrupt, and FEMA doesn't do anything. In fact, we talked to Southern Company, which is one of our neighbor utilities. So in the U.S., the utility companies already have an alliance. If your region get hit by a major disaster, the other regions will send people to help you. Okay, it's an alliance that they just form. They voluntarily helping you. Okay, the power companies. Okay, but Puerto Rico is very far away. Okay, so when Southern Company finally get all the equipment to repair their transformers, their substations, the ship went and FEMA would not let them get on the island.
So is this near Mexico, Professor? Closer side?
No. They're near Dominican Republic, and it's in the Caribbean. Yeah, yeah, far away from us.
Part.
Yeah, southern and more to the east. Yeah, and so system resilience. Just for those of you who doesn't know the term, it relates to how quickly you can recover from a disaster. So a disaster usually is multiple component, multifaceted. It's social, economic, humane, and engineering. okay, the physical system. But to recover from a disaster, we're talking about people willingness or have the strength to recover. So the first time when I present this to our utility companies, so I've been invited to give this talk several times, and I always use Danish coding as an example. There's always an alternative. When you had such a major impact, the 5,000 people just left, right, and abandoned the city. Many people say that New Orleans, after Katrina, people should just go away because we know the city is under sea. The chance of the next storm cover up, flood the whole city is very likely. So why are you people still want to stay in that area? So there are people saying that the government should not spend any more money to help them. Just move everybody out of that area. Because if climate change prediction is true about sea level coming, that place is going to be more and more vulnerable. So one of the resilience solutions is just walk away, because that will cost the least. There are a number of cities or historical towns worldwide that went through the same thing. A sudden cyclone or earthquake hits, and then everybody just move away because it costs too much, both psychologically, mentally, and financially to recover. So just go away. So that is the ultimate solution for resilience. Okay, that means zero resilience. People just go away. Okay, but if you have a good resilience plan, okay, maybe we can use technology to enhance, or certain technology would be faster to help recovery, and that is our interest. Okay, so use Dorothy Reed. He's the chairman of Washington University, and she's the frontier in defining great resilience. And she suggests the goal is to include engineering, design, technology, and see what is the best potential in enhancing a great system. Okay, and this is the biggest question that everybody's talking today in the U.S. Okay, and so just to give you some picture, so this is Puerto Rico. And usually the Atlantic Atlantic Ocean cyclone cycles goes from the forming of the cyclone on the west coast of Africa, and then it will travel to the east coast of the continental U.S. Okay, and so all these islands are annual. They get bombarded by the waves and the cyclones all the time. Okay, but by the time that the waves reach the U.S., usually it's not very strong. And that is why, in the past, our annual cyclone are 70 miles per hour, 80 miles per hour. Rarely you see one that's going over 100 miles per hour. Okay, but now it's happening every year. Okay, and this is the Puerto Rico island. It's a very beautiful island. It kind of reminds me of Sri Lanka. A big island with a high mountain range in the middle, and they don't snow, but the slopes are very steep. Okay, so driving through this area, the roads are very narrow, so it makes it even harder to repair the transmission towers, the transmission wires, and so forth. Okay, and this is the power grid. So the transmission highest is 230 kV, and most of which is 115, and then it downgrades to the distribution level. Okay, and this is the major distribution line. So you can see that it always surrounds the island because this is the mountain range where people don't live there. Okay, most people live on the coastal area. Okay, and these are the major regions. So it's separated into 1, 2, 3, 4, 5, 6, 7 zones. Okay, for the utilities. It's one big power company, PREPA, but then they have different region organizing. So when we request the data, we have to talk to each of the zones. Okay, and when Maria goes through, it hits the entire island. Okay, so everywhere you see transmission poles down, distribution poles down, and I'll talk a little bit about the renewable in a minute. So this is the Puerto Rico before the storm hits. and this is the after. So you can see just by night lights, okay, many of the area like Mayaguez completely lost their power. So no lights, okay. They have no lights for months, okay. When we go to Puerto Rico to present our work, have one of our meetings with them, it was 5 months after the event. 30% of the island still don't have power. So they don't have power for 5 months.
How did the people live?
Oh, they live in the worst stage you can imagine. You know, and that is a big issue.
Because without power, nothing can be done.
Nothing can be done, yeah.
They were there for 5 months.
They were there for 5 months, yeah. Okay, yeah, so you can see the data analysis. Okay, this is a very, so we now have a term called post-Maria Exodus. You know, Exodus is a book in the Bible that describes the Israeli people moving away from Egypt. Okay, there's a cartoon called The Prince of Egypt. It's talking about that story. But anyways, there are hundred thousands of people moving away from Puerto Rico. Many of them will not return. Okay, so then suddenly you have an island, have a void. And how, you know, now we're talking about who's going to rebuild the island. Okay, and many of those people have already decided they are not going back ever. Okay, because annual impact is just too much to bear. Okay, the infrastructure is too bad.
Migrated,
yeah, they completely migrate to the U.S., yeah. Almost every Puerto Rican has somebody in the continental America. Yeah, so they can live with their cousins, their uncle, whatever. Yeah, but this is a big issue because to recover, to rebuild the island, you have to have people to do the work, right? You have to have government members. You have to have people who construction crews and all that. So right now are people who are either contract or on voluntary basis to Puerto Rico to rebuild. Okay, and again, you know, so one of our going there is to analyze the data of all these damages. Okay, all the way from substations to and this is some of the structural damage that we see. So this is a building. Oh wait, yeah, a building on the coast. You can see how much the wave has impact and literally deplete. So Puerto Rico is not like the rest of the continental U.S. Those are all masonry structures. Okay, so we see the same kind of damage as in the Philippines. Okay, you can see this entire structures collapse because of wave impact. Okay, another view of this structure system. Okay, and a lot of the scourings and buildings just leaning and completely collapse. Landslide. So one of the major problems. Contrast to the Philippines, we don't see as much landslide because it's relatively flat. But here they have very steep slopes. And so they have a lot of landslides. Hundreds and thousands of them, literally. Yeah. Complete bridge being washed out.
What is the remedial solutions to prevent this landslide process? Soil nailing?
Cut it, making the landslide flatter.
Can we nail that?
Yeah. You can nail. But again, you know, in this area, the roads are very narrow, so you cannot bring heavy equipment up. Yeah. So the first thing they are doing is widen the roads. But even that is very challenging. You have to do a lot of cut. Yeah, very difficult. You know, just huge amount of landslide, and these are, you know, in the U.S. will be considered major landslide.
Lots of things is very common in the northern part.
Yep.
In the Himalayan range.
Himalayan range.
We have
right.
Landslides which we cannot predict.
Mm-hmm. Even this is not predictable. Yeah. Yeah. That's one area, and this is a dam, the spillway of a dam. You can see how much it was being washed out.
It's completely because of landslide process. This cause.
This is, I think, it's more because of the spill. The water spill out from the back of the dam.
Okay, it's the wear and tear.
Mm-hmm. Yeah. And we do more than 1,000 buildings inspected. Okay, so my student and I would travel all over the entire island and do a lot of inspection. Okay, and we do the same structural analysis. Okay, this work is partially done. We're still doing more. Okay, because just too much data. And Bharati knows we spend more than a month, right, with just Philippine data we analyze here at Trichy. So our students and my student and 8 of us, right, that we meet every day, just going through the data. Because we have over 20,000 images, photos taken. So we go through all the photos. My student put them in different categories based on the GPS position of the pictures. And then we go through them and rate every building. And solar. So this particular farm is completely depleted, yeah. And wind damage. Okay. So I told my students, we can design stronger structures. Okay, but for this one fellow, this is all his investment, and all his investors' money is gone. It will be another 10 years before he can get the many millions to rebuild this. Okay, so you cannot tolerate this kind of failures.
What would be the wind speed, Professor, when this has impacted? Probably.
Oh, that is 180 miles per hour. Yeah. Mm-hmm. And now we're doing a 10 kilometer and 5 kilometer grid. So we take the entire island. And the goal is to superimpose different damage modes. So we collect the landslide data, we collect the windstorm data, we collect the wind speed data, we collected flooding, all of that different hazards. And then we plot out the data and then trying to superimpose with energy usage data. Okay, and then see what caused the most damage for each of the zones. And then suggest the resilience strategy for that zone. Okay, so these are some of our analysis. I think this is the 5 kilometer. So coastal river erosion, the most happened in this area. Okay, and that's the river. So they have a lot of riverines. Okay, so riverine damage in the beach erosion is totally different. Okay, we differentiate them because the flood water may come from the river. Okay, and so this is the beach damage, and then this is the rainfall. Okay, so based on this data, we know that this region you have more significant rainfall, and the damage may be caused by the rainfall. Okay, storm surge, and so landslide. So this is a landslide analysis, and we can relate to the geospatial images and identify, what are the impacts. Okay, so this is a utility. So this is the night light before Maria. This is after, and then we can compare the difference and come up with our power loss data. So if I were to superimpose this image with, for example, this kind of images, then I would know that most likely the power outage in this region is due to landslide. Okay, so you have to do it in a statistical sense. Okay. So now we talk a little bit about power grid. Okay, so resilience ties in with every technology that you use to manage a power system. Okay, kind of like buildings. Okay, we know everything that goes into maintaining a building. You have to paint your walls every year, so that it keeps the air clean and keep the dust clean in the house. But those are just surface, right? It doesn't strengthen the building. So to strengthen your building, maybe every 20 years you go and check your brakes, or concrete if it's good, right? So you realize that everything that you can do to your house, it applies to a certain period. Okay, so painting your house, you can just go to a store, buy the paint. You can do it overnight. But to get concrete work, you have to estimate, you have to get people who know how to do concrete come in. That costs more money, takes more time, right? And so, same thing with power grid management. There are technologies that call the component hardening. You can build bigger poles, replace them with stronger components, right? But that would take a certain amount of time, right? You have to design, you have to send crews out and repair them, okay? You can do more frequent inspections. If you wood structures, maybe the birds or the erosion under the soil cause the woods to corrode. Then you replace them frequently. So all these are techniques that you can consider, because in resilience you consider everything. Or you can clear the vegetations. If you have a major power line, you clear the right of way so that the debris doesn't damage your structure. Okay. There is a survey. So as I mentioned, this is the most important topic for the power utilities in America right now. People are talking about how can we prevent next year spending another $1 billion in repairing our system. What can we do to make it stronger? Well, they did a survey of all the utilities in the southern part. Out of all these methods, this one, 60% of the utility companies say, all we have to do is just clean up the trees. Take the trees out, leave the utility lines clear, will probably prevent most of the failures. Well, that is their opinion. Okay. Till today, we don't know what is the real reason why we have so many failures. Okay, everybody knows that our system is more than 50 years old. Yes, they are old. But the power company also argue they have been updating, they have been modernizing the grid. But still, every year we see all this unpredictable. I mean, it's almost impossible for me to tell them we need to upgrade every structure. Like in my state, we have more than 1 million wood poles. You cannot replace all of them. Okay, even if every wood pole costs $1,000 US, that's $1 billion to repair all of them. Okay, and the utility company, their entire asset maybe just 100 billion. You're taking 1% of all their asset to replace those poles. I mean, financially impossible. Okay, and this is the kind of issues why we do this research and this kind of study. Okay, and then some people suggest the other things like smart grid or enhanced grid modeling, interconnections, adaptive islanding. Okay, making them self-sufficient in small zones so that when a storm hits, this region will not suffer, or they can generate power on their own and sustain for a while. So microgrid and all those ideas starts to form. Okay, but are they really the way to go? We still don't know the answer yet. Okay, and so if you look at the grid history, I mean a disaster history. Okay, the disaster usually has a time that comes in. Okay, and then suddenly there is a response using power system. Okay, because when people start realizing that tomorrow the storm is coming, they may suddenly turn off their electricity or air conditioning. So people have a reactive behavior. We using data analytics, we learn a lot of things about how people. So the last solar eclipse, I think it was last year or 2 years ago in America, everybody ran out of the building to see the solar eclipse. And then suddenly utility companies see a drop in electricity. Why? Because the room gets very cold. Nobody is in there, no heat. So the smart grid suddenly shut down the electricity use and downgrade the electricity use. So they see their energy use in the whole city suddenly drop because of that few hours. People were outside, not indoor. So they don't use that much electricity. So those are really, really interesting phenomena that using data analytics we can learn. Okay, and what we do using forensics in this case is adding more data to it. Okay, making the data more realistic, more useful. Okay, and then what do we hope for? We hope that eventually we can tell the utility companies, hey, this is the most important one, or this is the most important one. I mean, this blue line is the solution. So maybe this is the more important one. This is the most important one. But when do they implement those? We need to discuss and study. Okay, so this whole presentation is really to show you that forensic is a big business today. Okay, but not only that, can we apply what we know and what we specialize in into helping other components, like the power utility, okay, or water or sewer or something else, okay? Because when you are able to do a massive amount of forensic investigations, that data can be applied to help other decision making, okay? And always remember, infrastructure is not, the modern day infrastructure is interdependent, okay? And what we do using our expertise is to provide the ground truth, the reality of a disaster, so that the utilities and the rest of them can better use their assets in enhancing their resilience. Okay? And with that note, you also have to recognize that this is not a discussion about just today. Okay? There is a projection of to 2050, the climate change issue is going to be even worse. Okay? And so this becomes very real, okay, for many of us. And over the years, we have seen many companies specialize in helping power utility to recover, suddenly booming. Private companies suddenly get in. And there are a lot of companies specialized in energy storage, for example, suddenly come in and talk about climate change because they think they have the solution for all kinds of scenarios. Okay, so you realize that this is a very real for engineering field. Okay, any engineering field, this is a very real problem. Okay, so I wanted to talk a little bit about just the utilities solution. So EPRI, which is a electric power research institute, one of the major data dissemination organization, has conducted several studies, and they and FEMA and the U.S. government has some collective studies. And they come up with one solution, which is to build a mobile transformer. So they think the solution for American problem during those events is that when the power is down, you have to rebuild the power for people as quickly as possible. So during Harvey, okay, I didn't talk a lot about Harvey because we have not physically investigated the event. But during Harvey, the city of Houston was powered down for a long time, okay, a couple months, I believe, okay. But their issue is they have not strong wind, but they have flood. The city was flooded for a long time. So what happened was the FEMA has built one 345 kilovolt transformer, mobile transformer, okay? Only one, because that one cost more than $1 million to build. They wanted to ship it to Houston to help the people. They realized they couldn't ship it to the place. Even trains cannot move into the city. Cars cannot, trucks cannot. Nothing can move the transformer. So that transformer was totally useless for that particular storm. Okay? So you realize that we don't have a solution yet, okay, for many of those events. In fact, one of the things we learned from Vizag was really, the Vizag city was very quickly design mobile transmission towers, so they can move quickly to the site, but they don't have flood problem. Okay, so you have to understand a lot of those climate problems are multi-hazard. But being able to tell what is the predominant hazard, maybe you can design particular solution for that particular region. Okay, this is the best that we understand at this point. Okay, there are still many things that we don't understand. My student and I are still analyzing those data. But time will come. Yeah, we'll have very important. Recently, there was a paper published in the magazine of Nature. So MIT did a study of simulating the entire U.S. continental grid. And what's happening is, you may know more about this than the rest of us, but one of the problems with power grids failure is cascading failures. So the biggest problem is can we isolate, if this region has no power, can we prevent the other places not having power failure because of this one region? Okay, and so they did a simulation, and they were able to assess the whole continent of U.S. and then realized that that may not likely happen in the continent of U.S. But they only did one study for the U.S. There are 200 more plus countries that need to be studied. Okay, so resilience is also measured by how significant the damaged mode can be. Okay, from a utility perspective. Any questions? Yeah, I know this will be something really extreme. Okay, we're no longer talking about one single building. We're talking about massive amount of buildings.
You told failure Philippines. You have designed that for 1 kilometer
right
height.
Yeah.
No,
1 kilometer height. You mean the wave height?
Wave height.
Yeah.
That was we made an assumption, right? It's an assumption or?
Okay, so.
Because the actual fact, what was the height, we don't know.
Okay, I want to tell you. Okay, two aspects. Okay, first aspect. Remember, Philippines was part of the 2000 Asian tsunami, right? So Philippines actually has already updated their tsunami map, okay? And what happened to this case is, we know that cyclones bring storm surge, not tsunami. Tsunami is due to under ocean earthquake, right? And so in the Philippines, they actually have two maps for that region. One is called the hurricane storm surge map. Another one is called the tsunami map. And this particular storm, the water intrusion, the wave intrusion into the island was so far inland, the village people, the fishermen told them, if you tell us a tsunami comes, we would have all run away. And not so many people died. Because they don't understand the word storm surge. If you were to tell them, the cyclone comes and also comes a tsunami, they will all have been evacuated. But the people didn't leave because they thought it's just a strong wind force. They never expect that height. But that tells you that we don't really know how high the wave were.
But since we made an assumption that is 1 kilometer,
yeah.
Can we take from the geospatial data, especially that remote sensing,
yes.
that satellite, from that satellite image, can we able to sense what would be the approximate height of that?
Yeah. So both.
I don't know much about
yeah.
that.
No. Both Maria and the Philippine case was that the local receiver was being blown down. In fact, the Philippines, they have a brand new one. The Japanese built one. The organization, a brand new satellite, it was blown down. So they don't have any remote sensing data locally. Yeah, you cannot see the flooding from the satellite. Yeah, only the local antenna can tell you. Yeah, only the local receiver. So in both cases, the wind force is too strong for even those structures. Yeah, in fact, I tried to find my picture. We actually drove by, and the weather station was on the top of an island, and that like a ball-shaped antenna was all the way down the hill, so it was get blown down. So it didn't even use. It was brand new. Yeah. So from a sensor point of view, yeah, we need better structure, better systems. Yeah. But yeah, still something that's struggling. Any other questions? I know this may not be a typical topic for many of you, okay? But I mean, India shares the same kind of concerns, coastal area, Pondicherry, all the way up to.
Recently, we had a cyclone near some 120 kilometers away.
Uh-huh.
Gaja, the name
Gaja.
was Gaja cyclone.
Mm.
The wind speed was around 120
Kilometers per hour. Yeah, 120 is like 100 miles per hour. Yeah.
And lots of coconut trees.
Trees down. Oh.
Were down, and that area is completely damaged.
Yes, yeah. In fact, in the Philippines, there are so many coconut trees down, it literally become an industry. So they call it the coconut lumber. So they strip the trees and then cut it into lumbers for people to build their home. So it literally become an industry. There are so many of them down. When we were in Vizag, all the trees were down, and then the city put them together. The smell was horrible. So those kind of solid waste, is another issue that how do you address? Yeah, after Katrina. Oh, yeah. You can't even make paper. So in Vizag, they cannot make papers fast enough to consume the wood. That was done. Yes?
So the water height can be measured in remote sensing data?
Only close range, not in not on satellite. Yeah, satellite doesn't. Yeah, satellite doesn't tell the wave height.
Some kind of detailed data used has some data.
Yes, a lot of those are actually measured by local stations.
No, that doesn't give the height and so. Height information you need to have either a Boeing.
Right. Yeah. A buoy or something. Yeah. You have to have local measurement. Yeah. I mean, historically, those waves are not high. One of the historical highest wave was 1,000 feet. So, some areas like England, between England and Greenland, those areas, usually in the winter, the waves are super high. So high wave is not the issue. It's when the wave comes to your land, that's when you have to panic. Yeah. And now we're seeing more of those high waves. Yeah. So it's a big challenge. Yeah. And flooding. And that's another problem. A lot of those waves, they come inland, but because our protection are closer, now once they breach your inland, they're suddenly flooding. Because coastal are usually lowlands. So the flood will take long time to recede, and that causes a lot of problem. Florence, it was last year? Florence was last year or the year before? Last year? Yeah, so Florence was not a significant storm, but it caused a lot of flooding in my state. Okay, in fact, the highway completely disappeared because of the flood, and people see fish swim across why the fish cross the highway. They see fish swimming over the highway, and that was a problem because people, especially disease. So if normal people live in a flooded area especially in those areas, more than a week, you get all kinds of disease. And those are big problems. Even the first responders who sent in, many of them got sick because you'll be saving people and suddenly drink the
last year in Kerala. Human state, because of that.
Yeah. Mm-hmm. Yeah. So go ahead.
We have code for wind analysis. We have code, but for tornadoes for high speed, high wind speed, we have code in.
Yes.
Do we have any codal provisions?
Oh, yeah. There is code provision. So if you are in the likely tornado areas, they have design code requirements as well. Yeah, but usually it calls for special designs. Yeah, even I mean that's why if you look at the news, every year Americans die from tornado impact. Many people. Yeah, so even the codes are not sufficient.
It's the issue for several years now. Tornado effect.
Yeah.
In the US.
Mm-hmm. Yep. Actually FEMA has a design for underground shelter. So they always tell you, tornado comes, go underground. Yeah. There's no prevention. Yeah. Yeah, we also did some tornado investigations, but those pictures, this is more impressive. Yeah. Any other questions?
What is the situation now in this Puerto Rico? In this
Puerto
area?
Rico?
Yeah, Puerto Rico.
So right now they don't know. A lot of companies are still sending people in to help them repair. So, it becomes very political. Yeah, they are trying to fire the guy heads of the power company, and but there's no solution. And the federal government, Trump, hasn't made a decision what he want to do with Puerto Rico.
He's not bothered.
Yeah, I don't think he's bothered. Yeah, there's no Trump Tower on Puerto Rico, so.
That's right.
Oh, are we recording this? Yeah.
It goes on like
Maybe the mic can be.
Yeah. Yeah, it is still very sad. Yeah. But when I present this to the utilities, a lot of them, come to me and say, "Oh yeah, they just have to replace the power authority, then problem can be solved because once you remove the corruption, many things can be done." Yeah. But this goes beyond, just one utility. It goes very complicated. Yeah. So the people are still moving out of the island. In fact, when we go to the Puerto Rico, we brought 2 of the local students with us for the investigation.
She's asking why can't the transmission line
Go underground?
Go underground.
Excellent question. So many people ask that question. Okay, well, 2 reasons. One is the cost for taking overhead line to underground is about 5 times more expensive. So you're looking at significant more money
No, but trying to rehabilitate this wanted
to go underground. And the other thing is flood. So during Florence, Charleston, which is a coastal city, a lot of the underground pipeline, the cable are damaged because of flood.
In the US, it is mostly on transmission lines, or are there also underground?
Only big cities are underground. Yeah. Yeah.
We do make some insulation of that kind.
No, it's impossible. It's impossible. Yeah. Cable is something else. Think about megawatts. 2 few kilovolt of power.
5 times.
Yeah.
We do insulation, it
Yeah.
will go 10 times.
Yeah, I do a lot of utility works, and even I am not qualified to touch the thing, because you have special license, the hot license, otherwise you're not qualified to even touch it. Yeah, so it's a very difficult topic.
Today, one newspaper, one news came in the news. One MP, he was holding two tube lights beneath the tower line, and the 2 tube lights were glowing. I'll show you the paper cutting. It is quite interesting.
Yeah.
And he is going to sue that in the court. It seems.
Oh my
So he
goodness.
has taken some evidences with the help of the law.
Yeah.
It was very funny to see. But is it possible? It happens?
What?
He's saying the electricity is conducting.
In your body?
Then they took some testers and they did some indication. The light was glowing, it seems.
So the famous picture of Tesla. Tesla has been promoting for wireless power charging. So there was a picture of him sitting reading a book, and then there's a big sphere, his famous wireless, and that thing was having like rays of electricity coming out. That's not true. People know that picture is doctored. It's not a real picture. Yeah, he would die. He would surely die. Yeah. Even if you don't die, I don't think anybody will
No,
try.
I'm surprised. He was just
He's holding-
catching 2 tube lights and it is glowing. I don't know. It's a magic. It's a sort of a magic.
I don't know. Yeah.
ಎಫ್ಟ್ ಪಾಸ್ ಆಗಲ್ಲ ಅವನ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಇತ್ತು ಬಟ್ ಕರೆಂಟ್
Affect ಆಗುತ್ತೆ.
ಚಿನ್ನದ ಟೆಸ್ಟ್ ಎಲ್ಲ ಹಚ್ಚಿ ಪ್ರಾಬ್ಲಮ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಲ್ಯಾಬ್
Yeah. Installation, yeah.
The light is glowing.
That's not a problem, sir.
It's not a problem.
But they're not supposed to do all that experiment.
Right.
That too.
He exposed that. It seems to be very funny. I was very surprised with seeing that.
People will criticize later.
Yep.
I know.
That is what is happening. He want to take that issue to the court and he want to sue the people
Yeah.
who are involved.
No. You know, I have one of my senior professor. He was struck by lightning twice, but he was in his car. So you know, it is possible to insulate yourself. Yeah, and he was completely no harm to him. So his car was struck by lightning. Yeah. So you know, you can design to prevent yourself from getting, you know, megawatts of heat, of electricity shock. But yeah, I don't think we have done enough experiment to prove. Yeah. Any other questions? I don't know which one is correct. That one is 1 o'clock. This is 12:30.
This is correct.
Oh, okay. Yeah.
I think battery is done.
Ah, yeah. Okay, and today, yeah, today we
Yeah,
our
we are supposed to. The teams may get ready after
lunch.
lunch
Yep.
to show your presentations.
Yep.
Presentation.
So we have a
case studies.
class project for them to do investigation. Yeah.
So the last 3 days afternoons we will be engaged.
Mm-hmm.
So are you ready?
Yeah.
So you want some time after lunch, or we can start right away after lunch.
Right after. Okay. So we'll all come back here. Okay.
So
Yeah.
how many groups? Is it a one group or a
No, two groups. Yeah. And then you want to do it alone,
how many
right?
in each group?
3,
2 or 3.
2 or 3. Okay. Yeah.
Okay. I think then we can
Yeah.
complete that
Okay.
within an hour.
Yeah. That would be good. Mm-hmm. Yeah.
They are coming, Professor. I have invited
Okay,
those
that's 2 people.
for lunch
Good.
also.
Yeah. Uh-huh.
They will be joining us
Okay.
for lunch
Okay.
and immediately after lunch
I
we
have
can
sent you the
questions. That I will
the
look.
grade, the rating.
The
Okay. Good. Yeah.
You mean the question paper?
Yeah. No,
Or
no,
the day
no.
after exam?
No. I send you a presentation score rubric.
Today you
Yeah.
have
For the no. I sent it 2 days ago. So that's what we use to grade them.
Okay.
Yeah.
I'll see that. I got the question paper
Yeah.
in my mail.
Right.
Yeah.
And I sent you earlier a rubric. Yeah. Okay, so go eat lunch quickly.
Yeah.
ஹலோ லைவ் ஒன்றும் போயிட்டு இருக்கா? Chandru, P. Chandru, you registered, when you registered, man? Certificates, everything ready. Today means it's not possible. You register, keep with you. Bahubali aa gaya na.